what we shall be discussing today has to do with high current or high voltage expression, often along the street. When it is observed there is sudden uh, increase in brightness of lights, or at home there is sudden increase in the speed of fan, or the television, or the refrigerator making some sound, which we normally attribute to a faulty electric supply. But then you often hear it along the street, high current, high current, high current. But the correct expression for that is high voltage. Anyway, let's look at see the explanation via the four wires running across the front of our house. We have the first, second, third, and the last. The first one is often referred to as the red phase or red line, yellow, and the third is green. And of course, the last one is the neutral. Now, the voltage between any of these three with respect to the fourth is 220, as seen in this figure. The voltage between the red line and the neutral line is 220. The voltage between the yellow line and the neutral line is 220. The voltage between the green line and the neutral again is 220 volts, which is the normal domestic supply. But the voltage between red and yellow, or between yellow and green, or between red and green is not 220. It's rather a relatively high voltage, 415 to be specific, 415 volts. Look at between red and yellow once again, between red and green, or between yellow and green is enormous voltage, 415 volts. Then what is responsible is simply because these three lines are not on the same phase. The same phase is something one can think of as originating from the source, because these three coils producing these three lines are not on the same level. Let's just put it like that. So when one is at the peak, the other one is at the middle, while the other one is just starting. That is what we mean by they are not on the same phase, but they are operating at the same frequency because they are in the same generating machine. But then what we really want to explain is which is correct between high voltage and high current when we notice sudden increase in brightness of the bulb due to a fault. Anyway, we say high current, but I said the correct answer is high voltage. But what happens in two ways? Things that normally happen along the street. One, any of these red or yellow or green could snap, in other words got cut off. It could even be from the transformer, whereby you have the fuse connected to red could get melted or blown up. Then you have yellow and green still left on. So those on this red line, of course the red line will be connected to the with the this thing neutral in each in the separate house. So those are on R and this end will not have light, but those on yellow and green will have light. Even if R and red and white goes off, snaps or whatever, green is on. Those on this green line will still have the light. But if this neutral line gets cut off, usually that's where the problem comes. Supposing it snaps somewhere around here, and this area, this source is coming from the transformer. This way is towards the end of the wires, because the wires will eventually end somewhere, but this one is the source. So all houses here As long as these three lines are still on with this neutral, all houses towards this direction will have their lights okay, 220. But here towards this direction will be where the problem is. In other words, the three lines are still intact, but the neutral line has snapped. In other words, this neutral is more or less like a free wire. Now, so what do you observe? Somewhere in each house, don't forget that all appliances are connected through to the most appliances are connected to these neutral lines for domestic use. This is connected, this is connected, this is connected, but this is no more operational. So what happens? You have what we call leakage from either the red or the yellow or the green, or from the three of them, because some appliances like refrigerator, AC might be on, and some other many other appliances. So what you observe is there is current on this neutral line. And those that have the practical experience, when you go for example, you have a tester, use it to test the socket, you discover that both the neutral and the live be showing light. Why? The neutral is showing light, the live is supposed to show light, that one is okay. But what about the neutral showing light? And then I told you it's a free wire, so there is leakage between this or both or the three into this neutral. That's why you see the neutral line showing light. So what happens eventually? It simply means there is leakage of electricity from either this or this or this into this. And mind you, we have said that the voltage between red and yellow, or between yellow and green, or between red and green is 415 volts. So supposing green, there is green leakage now into this neutral line wire. I will call it ordinary wire now, neutral line. So what happens? Anything connected, let's say red, that is now that is connected, or a bulb that is connected between this red and this neutral, you are supplying 415 volts to it. That is why you see it being extra bright. That's why you see your fan at extra speed, etc., etc. So I would like you to ask questions and comments, and like or share as the case may be, or subscribe. Thank you.